Wabarakatuh and good afternoon. Okay, so I think we can start our lecture now. Okay, so today basically we will start with a new chapter, which is chapter 2, Amplitude Modulation, Transmission and Reception. Okay, so if you still remember what you have learned in chapter 1, okay, so in chapter 1 you have learned on the basic communication block diagram. Okay, so the communication block diagram actually consists of the sender. I hope you still remember this. So you have the sender, and then the sender will send the information, and then it will go to the modulator. Okay, so after the modulator you have the transmitter. And then you have the channel. After channel you have the receiver. And then after receiver you have the demodulator. After demodulator you have the recipient. Okay, so this one is covered in chapter 1. So I hope that you already understand how this communication system works and also the function of each of this block diagram. Okay, so in chapter 2, basically we will concentrate on this part, the modulator part. Okay, so this modulator, actually there are several types of modulator. We have amplitude modulator. We also have frequency modulator. Okay, and then we have phase modulator. And we also have digital modulator. Okay, so for example, in chapter 2, we will concentrate on amplitude modulation. Okay, frequency modulation and phase modulation will be covered in chapter 3, and digital modulation will be covered in chapter 4. Okay, so basically in chapter 2, we will learn about amplitude modulation, how it works in detail. Okay, the process of the transmission and the reception. Okay, so now let's look at what is modulation. Okay, so if you still remember the function of the modulator itself. So basically the function of the modulator is to convert original signal or the information signal that we want to send into a signal that is suitable for the transmission channel. Okay, so that's why stated here. Okay, we have this statement over here. It stated that normally signals that we want to send are not in the form that is suitable for transmission, and that's why it needs to be transformed. Okay, so how to transform? That is why we need a modulator. And this modulation process is the process of applying low frequency information signal onto a relatively high frequency carrier signal. So if you look at this statement here, you will basically know that the input of the modulator, you will have two signals. So the first one is a low frequency information signal, and another one is a high frequency carrier signal. So if you look at this figure over here, this is the modulator, and you have two inputs. Okay, so this is the first input. The first input is the modulating signal, or we also call it as information signal. Okay, so this is the information that we want to send. Okay, example of the signal is the speech signal or voice signal. Okay, so this is the information that we want to send. Modulating signal, or sometimes we also call it as information signal. Okay, and this modulating signal, the frequency is a low frequency. Look at here, a low frequency information signal. Okay, so another signal that we have is the unmodulated carrier, or usually we call as the carrier signal. Okay, this is the carrier signal, and this carrier signal, the frequency is high. Okay, so you look at here, high frequency carrier signal. Okay, so this is low frequency, this is high frequency. Okay, so the process of modulation is applying a low frequency information signal onto a relatively high frequency carrier signal. Okay, so this is the signal that we want to send. This is another signal that we generate. And the output, you will get the modulated signal envelope. You will get something like this. Okay, so this is a basic concept of the modulation process. So why do we need modulation? Okay, so previously you already know that you need modulation in order to convert the information signal into a signal suitable for the transmission channel. Okay, and this channel need to be transformed in order to fulfill all of this. Okay, it must fulfill the bandwidth requirement, the signal multiplexing, complexity of the transmission system, and also to prevent noises, interference, and also attenuation. Okay, so this one I already explained. So modulation, okay, I've already explained before that we have several types of modulation. We have amplitude modulation that will be covered in this chapter. Frequency modulation and phase modulation will be covered in chapter 3. And we also have the digital modulation that will be covered in chapter 4. Okay, so now let's focus on the amplitude modulation. Okay, so what is amplitude modulation? Okay, so the definition here is that it is a process of changing the amplitude. Okay, so the keyword here is changing the amplitude of relatively high frequency carrier signal with the instantaneous value of the modulating signal or the information signal. Okay, so amplitude modulation, basically it changes the amplitude. Frequency modulation, it changes the frequency. Phase modulation, it changes the phase of the carrier signal to follow the, for example, the amplitude of the modulating signal. Okay, so let me draw the modulator block diagram again. Okay, so this is the modulator. Stated over here, you have two inputs. I already told you before that we have two inputs. The first one is the modulating signal or the information signal. So this one, the information or the modulating signal, information signal, low frequency, we define it as VMT. Okay, VM is modulating signal, VM. The second signal is a single high frequency carrier signal of constant amplitude. Okay, so the second signal is the carrier signal. And this one we name it as VCT. Okay, C is carrier. Okay, and I've already told you before that this modulating signal is a low frequency. Okay, another signal, the carrier signal, is a high frequency. Okay, so the output of this is an amplitude modulator. Yeah, So the output of the AM modulator, you will have something like this. Okay, so this one we call as the modulated signal. Okay, since it is an amplitude modulation, then we name it as VAM. Okay, amplitude modulation, or we call it as the modulated signal. Okay, so this is different. This is modulating, this is modulated. Okay, two different signal. Modulated is the output, modulating is the input. Okay, and if you look at here, the process amplitude modulation is the process of changing the amplitude of the carrier signal to follow the amplitude of the modulating signal. So you can see that over here, carrier signal has a fixed amplitude. Okay, and this modulator actually changes the amplitude of this carrier signal so that it follows the amplitude of this modulating signal. So that is why you will get something like this. It changes the amplitude of the carrier. This is the carrier. So it changes the amplitude of the carrier so that it will follow the amplitude of the modulating signal. Okay, so this is the what we call as the amplitude modulation. Okay, and this signal, the output signal, this one, we call it as AM envelope. Okay, so this is AM envelope. Okay, so next, this one. Okay, so this one, VMT is equals to sine 2 pi FM T. And the carrier signal is VCT equals to sine 2 pi FCT. Okay, so both of this is a sine wave. Okay, sine wave. However, you can see that from the signal, the frequency for VM, for the modulating signal, is lower compared to the carrier signal. Okay, so the most commonly used AM modulation technique is the AM double sideband full carrier, DSBFC. So this is what the AM modulation technique that we will focus in this subject. Okay, so we will only cover for the AM double sideband full carrier. Okay, so this one already explained. This is the input carrier signal equals to VC sine 2 pi FCT, and we have another input modulating signal VN sine 2 pi FMT, and this is the output VAMT. Okay. Okay, so in the previous slide, okay, I already told you that the output of the modulator, we can get the signal in the form of AM envelope. Okay, so remember you have the modulator. Okay, so the output over here, in the previous slide, you will get the output like this. Okay, so this is what we call as the AM envelope. Okay. However, at the output, we can also get the signal in terms of frequency spectrum. Okay, so other than the AM envelope, we can also get the output frequency spectrum. Okay, so you will get something like this. So this is the example of the frequency spectrum. Okay. So usually we will draw it like this. So this figure over here is just to show you that the signal in the middle is the carrier signal. Okay, so this is the carrier signal with the frequency Fc. Okay, and then this part over here we call it as the lower side frequency. Okay, so the frequency at this parts over here to the left hand side is the lower side frequency, and the frequency over here is we call as the upper side frequency. Okay, and the band here, okay, we call as the lower side band. This one is the upper side band. Okay, so basically lower side band consists of several lower side frequencies. Upper side band consists of several upper side frequencies. Okay, band of frequencies. Okay, and if you look at here, the limits over here, so this is Fc, and at the lower side frequency, this is Fc minus Fm max, and the limit at the upper side band is Fc plus Fm max. Okay, so basically you can know that the spectrum ranges from Fc, okay, ranges from Fc minus Fm max to Fc plus Fm max. Okay, so from here you can actually know that you can actually know the value of the bandwidth. Okay, so the bandwidth is basically from this point here until here, the range. Okay, so this is the bandwidth. Okay, so bandwidth is equals to, if you look at here, from this point to this point is equals to Fm max. From this point to this point is equals to Fm max. Okay, so the bandwidth is actually Fm max plus Fm max. So it is actually 2 Fm max. Okay, so this is the formula for bandwidth for the amplitude modulation. Okay, so B is equals to 2 Fm max. Okay, so Fc is carrier frequency, Fm max is modulating signal frequency. Okay, next, so this slide actually explain to you the parameters stated in this figure over here. Actually, I already explained. We have the lower side band. It is a band of frequency between Fc minus Fm max until Fc. Lower side frequency is any frequency within the lower side band. Upper side band here is a band of frequency between Fc until Fc plus Fm max, and the upper side frequencies is any frequencies inside or within the upper side band. Okay, and this one already explained to you how do we know that the bandwidth is twice the highest modulating signal frequency. Okay, B is equals to 2 Fm max, twice the highest modulating signal frequency. Okay, so now let's do an example. So this example stated that for an AM DSB-FC modulator with the carrier frequency Fc equals to 100 kHz and the maximum modulating signal frequency Fm max equals to 5 kHz, determine the frequency limits for the upper and lower sideband. Okay, so let's do the first one, the frequency limit. Okay, so let's do the lower sideband first. For the lower sideband, okay, the limits is from Fc minus Fm max Okay, until FC. Okay, so remember the frequency spectrum that I just showed you just now. The lowest side band, the frequency is from FC minus FM max until FC. Okay, so FC is 100K minus 5K until 100K. Okay, so basically the limit for the lowest side band, the frequency limit for the lowest side band is from 100K minus 5K is 95 kilohertz to 100 kilohertz. Okay, so this is the frequency limit for the lower side band. For the upper side band, okay, so the frequency limit is from FC to FC plus FM max. Okay, so FC is 100K plus 100K plus 5K. So it's basically the limits is from 100K to 105K. Okay, so that is the frequency limit for the upper side band and the lower side band. Okay, so the second one, please calculate for the bandwidth. The bandwidth. Okay. The bandwidth I already. Okay, bandwidth is 10 kilohertz, correct. Okay. So bandwidth is 2 FM max. Okay. So 2 multiply with 5K, so equals to 10 kilohertz. Okay. C, upper and lower side frequencies produced when the modulating signal is a single frequency 3 kilohertz. Okay, so the question asks you to calculate the upper and lower side frequencies. Okay, so for the upper side frequency, FUSF is equals to FC plus FM. The FC is 100K, FM is 3K, so plus 3K. Okay, so the answer is 103 kilohertz. Same for the lower side frequency. Lower side frequency is FC minus FM. FC minus FM. Okay, so 100K minus 3K, you should get 97 kilohertz. Okay. Okay, so and the last one, the question asks you to draw the output frequency spectrum. Okay, so remember the signal in the middle is the carrier signal. Okay, and then you have the first signal. So usually we only have three signal, FUSF, carrier signal, and also FLSF. But since these questions, you have been given two frequency. The first one is FM max. The second one is FM equals to 3K. So you need to draw both signals. Okay. So the first one here, the frequency is, so this is 100K. And then this is 97K. This one is 95. And then we have 103K. And also the limit, the maximum is 105. Okay. And the unit is hertz. Okay. Okay, so since this question doesn't give you the value for the VC and VM, so you don't need to put the values here. The values for the upper side frequency and lower side frequency, the amplitude. Okay, but if the questions give you the value for the VC and also VM, then you need to put the values, okay, in the frequency spectrum. Okay, so any question for this example?
No.
Okay. Okay, so next we can proceed to the coefficient of modulation and percent modulation. Okay. Okay, so what is coefficient modulation? Over here, coefficient modulation is defined as the amount of amplitude change present in an AM waveform. Okay, and this coefficient modulation is we define as M, small m, yeah, small m for coefficient modulation, and the formula is EM divided by EC. Okay, so EM is the modulating signal amplitude. EC is the carrier signal amplitude. Okay, another one we have the percent modulation. So percent modulation is the coefficient of modulation stated as percentage. Okay, so percent modulation is actually this coefficient modulation but in percentage. So we define percent modulation as M, capital M. Okay, this is percent modulation. So percent modulation is equals to EM divided by EC multiply with 100% or equals to small m multiply with 100%. So basically coefficient modulation and percent modulation is the same thing. However, percent modulation is in percentage. Okay, and you need to know that the modulation coefficient, it varies from 0 to 1. Okay, so the values for small m is from 0 to 1. So if for example you calculate and you get the value more than 1, maybe you will get 3, then it means that your answer is actually wrong. Modulation coefficient, you must get the value between 0 to 1. Okay, so that if you calculate for the percent modulation, so if you get coefficient modulation is equals to 1, then you multiply with 100%. So your percent modulation, you will get 100% modulation. So 100% is the maximum. Okay. So EMEC is actually the remember your carrier signal VCT. So VCT is actually EM sine 2 pi, sorry, this is EC, 2 pi FCT. To pi FCT. Okay. For modulating signal, we have VMT equals to EM sine 2 pi FMT. Okay. So EC is actually the same as VC. EM same as VM. Okay, the amplitude. Okay, so this is actually voltage. EM and DC is the voltage. Okay, so next. So remember, this is your AM envelope. This is the output. You will get something like this. Okay, so if you have the output in the form of AM envelope, you can actually label the Vmax and also the Vmin. Okay, so Vmax is the maximum, Vmin is the minimum. Okay, and from this AM envelope also, you can actually determine that the value from 0 until somewhere here is equals to EC, and from this point until the maximum is equals to EM. Okay, so actually you can derive from this equation, okay, Vmax and also Vmin, you can try to derive this. You will get EM is equals to 1 over 2 Vmax minus Vmin, and EC equals to 1 over 2 Vmax plus Vmin. Okay, so this formula you need to remember. So don't get mixed up. EM minus EC plus. Okay, so basically if you are given this signal, the output signal, you can actually calculate for the modulating signal and also the carrier signal. So you just use this formula, 1 over 2 Vmax minus Vmin, and EC is equals to 1 over Vmax plus 1 over 2 Vmax plus Vmin. And over here you can see that Vmax is actually equals to EC plus EM, while for Vmin it is actually EC minus EM. Okay. So for this AM envelope, okay, please take note that if you have modulation coefficient equals to 1, okay, this actually means that you have 100% modulation. So if you have 100% modulation, you must make sure that you draw your AM envelope like this. If you have 100% modulation, M equals to 1, you will actually get the Vmin here is equals to 0. Okay, so later I will show you how when the modulation percentage is 100%, the Vmin is 0. Okay, so if you calculate your percent modulation is 100%, you must draw like this. You cannot draw with the gap like this. Okay. And also from this output AM envelope, you can also calculate for the modulation coefficient. Okay, so previously you already know that percent modulation is M equals to EM over EC multiplied with 100%. Okay, but what happens if the questions doesn't gives you EM and EC, but instead it gives you this figure? Okay, so you can use this formula. Okay, Vmax minus Vmin divide by Vmax plus Vmin multiply with 100% because you already know that